Okay, as we continue on this fantastic unit all about circles, let's see if we can find angle and arc measures. Bum, 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 bum. So, what if we got a tangent and intersected chords? Right? The chord meets that tangent line, or it's tangent to the circle. In this case, the measurement of each angle is 1/2 the measure of its intercepted arc. Remember, if we had an inscribed angle, it was half the arc. And this is almost like an inscribed angle, except the angle actually has a tangent as one of its rays. So angle 1 has to be half the measure of arc AB. Angle 2, the measurement of angle 2 has to be half the measurement of arc BCA. If you think about it, the circle has to have a grand total of 360 degrees. Of course, an angle that makes a straight line is 180 degrees. So, you know the grand total of the line has to be 180 degrees. You know the grand total of the circle has to be 360 degrees. So half of each arc equals the angle that it subtends. Okay, so let's try this here. Line M is tangent. So, for example A, it looks like we're searching for the measurement of an angle. Well, we know its arc is 130 degrees. So the measurement of the angle has to be half of that arc. Half of 130 is 65. Okay, this time we know the angle is 125. We're looking for the arc. Well, if the angle is half the arc is double the angle. Double the 125, we get 250. So the measure of arc KJL is 250 degrees. Yeah, that seems straightforward enough. Now, what if the lines actually intersect each other somewhere? Right? Now, if the lines are not parallel, they have to intersect because we're talking two-dimensional here. So we're not going to have any skew lines, right? Because we're all two-dimensional. So the lines have to intersect each other, and the lines have to intersect the circle. Now, where the lines intersect could be on the circle, inside the circle, outside the circle. Right? Those are our three situations. Okay, so what if we are inside the circle? Right? Not necessarily at the center, right? I don't have central angles. They're just somewhere inside the circle. So they're not central angles. They're not inscribed angles. They're not angles formed where the tangent intersects the chord. They're just angles floating around somewhere inside the circle. Well, each angle has a measurement that's equal to half the sum of the measures of the arcs intercepted by the angle and intercepted by its vertical angle. So in this diagram, notice that they've got two arcs highlighted. They've got arc DC highlighted in red, because that goes with angle 1. And then they've got arc AB highlighted in blue, because that goes with the angle that is vertical to angle 1. So if I wanted to know the measurement of angle 1, I have to do half of the sum of those arcs. In other words, I have to find the average value for those two numbers, right? The arithmetic average, not the geometric mean, the arithmetic mean. And angle 2 would therefore be the average of the other two arcs, right? Arc AD would be the arc that goes with the vertical angle from angle 2, and then arc BC would go with angle 2. Now, if the intersection is outside instead, this is where it gets crazy, because these lines that intersect the circle could be secants or tangents. But notice, instead of adding the measures of the arcs, we're going to subtract the measurements of the arcs. Right? So in this first case, we've got a tangent and we have a secant. They intersect outside the circle. Measurement of angle 1, 1/2 the difference of the arcs. Hey, I've got two tangents that intersect outside the circle. Same method, find the difference of the measurements of the arcs and then multiply by half. If they're both secants, same thing, find the difference in the measurement of the arcs, multiply by half. So if they intersect inside the circle, we add the arcs and divide by 2. If they intersect outside the circle, instead of adding, we subtract the arcs and then divide by 2. So let's try a couple of these with numbers and see if it's starting to sink in a little bit. Okay, got an angle X. I know the angle X goes with the arc that measures 156 degrees. Of course, angle X also has a vertical angle, and the vertical angle goes with that lovely arc with 130 degrees. So if I actually want to figure out the value of X, I add those arcs together and then divide by 2. Alright, add the arcs together, divide by 2, comes out to be 143. That's the value of X. Now, if the lines or line segments intersect outside the circle, in this case it looks like we got a tangent and a secant. Instead of adding those arcs, we subtract. 178 minus 76 would be 102. Divide that by 2, and we get 51. Okay, the circumscribed angle is the angle whose sides are tangent to a circle. Right, so this is the case where the lines intersect, they also intersect the circle, but instead of one tangent and one secant, or two secants, we actually have both of them being tangents. Well, if they're both tangents, that circumscribed angle is equal to 180 degrees minus the measure of the central angle that intercepts the same arc. So notice that segment AC, of course, would be a radius. Segment BC, of course, would be a radius. And so we've got angle ACB. Right? Angle ACB would be subtended by arc AB. So I'm saying, hey, the measure of angle ADB would be 180 degrees minus the measure of angle ACB. This will probably be a little bit more clear if we do an example that has numbers in it. Alright, so I've got that angle floating out there, angle ADB. Of course, we've got that arc AB. And then we got that central angle, 135 degrees. All right, now the measure of angle ACB has to equal the measure of arc AB. The central angles and their arcs are equal to each other in measurement. I know the measure of angle ADB is 180 degrees minus angle ACB. And so it's a 45-degree angle. This diagram, boy, I think we're going to need a lot more real estate to figure this thing out. What can we do? Well, I know the measure of angle EJF has to be half the measurement of that arc EF. How am I going to figure out the measurement of that arc? Well, I also know that the measure of angle EJF has to be half the measure of the angle EGF. Now, at this point, if you think I've lost my mind because you're like, hey, I don't see an angle EGF. I don't think we've had to do this yet this year, but sometimes when we're in geometry, we have to add things to the diagram we're given. And so I can add the radius to the picture, EG, and I add the radius FG to the picture. So there is the measure of angle EGF. Now, if you're saying, well, how do you know that one angle is half the measurement of the other angle? Okay, arc EF. You know that has to have the same measurement as angle EGF, right? Because the arc has to have the same measurement as that central angle. But the inscribed angle only has half the measurement of the arc. Now, angle EJF, we know it's going to be 1/2 180 degrees minus angle EHF. Right? Because I know the measurement of angle EGF is 180 degrees minus angle EHF. All right, 180 minus 30 divided by 2 gets us 75. All right, IXL is a little bit of a throwback here. Area of parallelograms and triangles. So if you complete the worksheet, I think you'll find that IXL pretty straightforward.